Here we go.
Going in 5, 4, 3, 2, 1.
Hey everyone, this is our submission video for the Tripoli Rocket Launch in the Argonia Cup Challenge. My name is Jacob Russell, and we are Western Michigan University's Pegasus rocketry club from AIAA. I am the rocketry lead, and these two are the two sub-team leads.
I'm Andrew, and I'm the lead for the payload team.
I'm Jonathan, and I'm launch vehicle design.
Hi, I'm Devin Singer, and I'm a senior in aerospace engineering.
Hey, I'm Stephanie Howard. I am a first-year aerospace engineering student.
Hi, my name is Ethan Reed. I'm a second-year aerospace engineering major here at Western.
Hi, I'm Rachel Cabin. I'm a first-year aerospace engineering student here at Western.
Hi, I'm Alexis Lind. I'm a first-year aerospace engineering major.
Hi, I'm Alec. I'm a second-year aerospace engineer at Western Michigan University.
Hi, I'm Chase Ragland. I'm a fourth-year aerospace engineering student.
Hello, I'm Coriana Boston. I am a freshman and I am majoring in nursing.
Hi, my name is Matthias Stremler. I'm a third year and I major in aerospace engineering.
My name is Aiden Wales, and I'm a sophomore in aerospace engineering.
My name is Nate Owen, and I'm a freshman in aerospace engineering.
My name is Mason Shadle, and I'm a senior in mechanical engineering.
Hi, I'm Kyle Chilla. I'm a third year in aerospace engineering.
Hi, I'm Logan Heffern. I'm in my second year and I'm majoring in aerospace engineering.
Our launch vehicle is a modified DX-3 XL rocket by Medco Rocketry. This airframe was chosen as its spider diameter allowed additional room for our payload design, as well as a vent logger and a flight computer in our electronics bay. The airframe, fins, and nose cone are fiberglass with an aluminum nose tip and tail cone. The rocket is 10.2 centimeters in diameter and 253 centimeters in length, a modified airframe length from the original DX-3 to increase static stability at launch condition. This configuration with a loaded payload and motor results in a static stability of 2.18 calibers. Our simulations have shown an apogee of approximately 9,100 feet. This would allow us to reach our design minimum acceptable apogee of 9,000 feet, a 1,000 foot margin of error in erratic flight conditions. The chosen motor is the Aerotech L850WP, with a total impulse of 3,695 Newton seconds over a 4.2 second burn.
Hi, I'm Jasmine. I'm part of the payload team for the Argonia 2019 competition. I am researching the aerodynamics of different types of parachutes, and we're working on a parafoil, and we have came up with different types of experiments, such as the truck experiment that we have here, where we just attach the parachute and measure the dynamic pressure. And me particularly, I'm working on also making different, I also thought of brainstorming different types of experiments to collect data on the dynamic pressure and any type of aerodynamic performance parameters we need. And I also do the mathematical analysis heavily.
And we decided to go with a guided parachute system as our recovery method for the payload for this competition. Our control system is Arduino based, requiring intensive programming, which happened to be our largest challenge facing the team this year. On top of that, we did a bunch of 3D CAD models in SolidWorks, allowing us to produce and 3D print multiple prototypes of our payload structure before we completed it.
On board our payload, we have a few different instrumentation units. So we have an accelerometer, barometer, gyroscope, and GPS. We are taking values from these instruments and we're feeding it through an Arduino, which is going to be controlling 4 servos, which will ultimately control the direction of our parachute.
Altogether, that is going to be approximately 2 kilograms.
The parts in red will be made out of aluminum and have been 3D printed in the past. In orange, we will have our power source. Next to it is our control system, cellular, GPS, and accelerometer. And here we have our payload, which is a golf ball. Down here, we will have our servos, which will control the parachute upon deployment. All the parts have been evaluated for how much stress they will face during flying conditions. To connect this to the nose cone, we will use a threaded rod.
That was the design process that we've gone over for the past year now, and we're ramping up to go to this competition on March 30th. I'm really excited for WMU to make its first debut into the rocketry competition scene. Pegasus is going to make its first flight with Pegasus 1. Thank you all for listening. This is Jacob Russell, and I hope that the Broncos fly high.